Climate change is a problem that affects everyone, everywhere. We're seeing higher sea levels and an increase in natural disasters that are becoming more frequent and intense. On top of that, rising temperatures are leading to droughts, wildfires, and even crop failures. But don't lose hope just yet. There are ways we can tackle and even reverse some of these effects if we come together and use new technologies. In this video, we'll dive into some of the most promising solutions. First, we'll explore carbon capture technologies. After that, we'll check out some other exciting inventions that could help us in the fight against climate change. So, make sure to stick around till the end. Carbon capture and storage is exactly what it sounds like. Capturing carbon dioxide emissions from industrial sources, then treating and transporting it to be stored deep underground in geological formations. Direct air capture, DAC. DAC technology uses special air filters to pull CO2 directly from the air. Once the CO2 is captured, it's concentrated and then either stored or turned into useful products. Although this tech is still new and pretty expensive, with more research and scaling up, it has great potential to help reduce atmospheric carbon emissions. Cryogenic carbon capture, CCC. CCC is a newer technology that uses extremely low temperatures to capture CO2 from gas streams. By cooling the gas to very low temperatures, CO2 can be extracted more efficiently than with traditional methods and stored in a smaller volume. While CCC is not widely used yet, it has great potential to reduce carbon emissions as the technology improves and becomes more widely adopted. Carbon capture, using nanotechnology. This cutting-edge approach employs nanomaterials like carbon nanotubes to capture and store CO2 at significantly lower pressures compared to traditional methods. By utilizing nanotechnology, this method consumes fewer resources, requires less energy, and generates less waste than other carbon capture technologies. While still in the experimental phase, carbon capture using nanotechnology shows great potential due to its scalability and efficiency. Carbon capture at power plants. This method involves capturing CO2 emissions directly from power plants before they can escape into the atmosphere. The captured CO2 is then compressed and transported either for storage or for use in enhanced oil recovery. While it has some limitations, it's currently the most commonly used carbon capture technology and can play a big role in cutting down carbon emissions. Enhanced rock weathering, ERWW. Enhanced rock weathering, ERWW, involves spreading crushed silicate minerals and rocks like basalt and glauconite onto the soil. This speeds up the natural weathering process, which normally takes millions of years, and increases the soil's ability to capture CO2. A major plus of this technology is its efficiency and cost-effectiveness, as it also boosts soil fertility. Bioenergy with carbon capture and storage, BCES. BECCS captures CO2 from biomass energy production using organic materials like plants and waste and stores it. This process not only traps emissions but also generates electricity, making it a carbon-negative solution. It removes more CO2 from the atmosphere than it emits. As a low-carbon energy source, BECCS has the potential to play a major role in reducing the carbon footprint of our economy. Chemical looping. Chemical looping uses metal-based particles to react with carbon dioxide, CO2. These metals act like a catalyst, which means they help separate the CO2 from the fuel without being used up in the process. After this, the CO2 is captured and stored, while the remaining fuel is burned for energy. Although this technology is still experimental, it holds promise for cutting down carbon emissions from industries that heavily use fossil fuels. Aqueous amine-based CO2 capture. This technology uses amines, which are organic compounds derived from ammonia, to capture CO2 from industrial emissions before they escape into the air. The CO2 is then separated from the amines and sent off for storage or reuse. Membrane gas separation. This technique employs permeable materials to filter out CO2 and other gases. It's energy efficient and cost-effective because it works at low temperatures and pressures. Although still in the experimental phase, membrane gas separation shows great potential for capturing, separating, and storing CO2. Carbon capture and conversion. This innovative technology captures CO2 and transforms it into useful products like fuels, industrial chemicals, and polymers. Though it's still in the early stages, carbon capture and conversion offer a sustainable way to lower our carbon footprint while creating valuable goods. And here are further inventions that could lend a hand in our battle against climate change. Ocean fertilization. Ocean fertilization is all about giving the ocean a nutrient boost to kickstart the growth of tiny plants called phytoplankton. These little guys are super important for keeping the ocean healthy and supporting its diverse life. Plus, they can help us out by sucking up carbon dioxide from the air through photosynthesis. Ocean fertilization sounds like a game changer, but there are some things we need to think about. One worry is that it might mess with ocean life in ways we don't expect, or even lead to harmful algae blooms. Plus, we've got to figure out if it's really practical to do this on a big scale, and how much it's going to cost us to pull it off. Cultured meat products. It might surprise you, but changing how we raise livestock could actually make a big difference in the fight against climate change. Traditional cattle farming has a huge impact on the environment, from pumping out greenhouse gases to gobbling up land and polluting water. But there's a new kid on the block: cultured meat. This futuristic meat alternative is all about growing muscle tissue from animal cells in a lab. It could slash the need for traditional livestock farming and all the environmental headaches that come with it. Plus, it's not just good for the planet, it's also a more humane option, since it doesn't involve raising animals just to turn them into burgers. Space-based solar power. Imagine harnessing the sun's power from space and beaming it down to Earth. That's the idea behind space-based solar power. Instead of placing solar panels on the ground, we'd stick them up in orbit and zap the energy back to Earth using microwave or laser beams. It's a cool concept that could give us a reliable source of renewable energy, especially in places where traditional solar power isn't practical. Atmospheric sun shading. Solar geoengineering is all about bouncing some of the sun's rays back into space, kind of like putting up a giant umbrella to cool things down. The idea is to tackle global warming by reducing the amount of solar radiation that hits the Earth's surface. It's like finding shade on a hot day to avoid getting sunburned, only on a planetary scale. The goal is to balance out the heat trapped by greenhouse gases with a bit of extra sunblock in the sky. But, as with any big idea, there are potential hiccups. One study suggests that playing with the sunshade could mess with rainfall patterns, which could cause all sorts of headaches. That wraps it up for today. Thanks for tuning in, and I'll catch you in the next one. Until then, take care and goodbye.